Hello everyone, I am Dr. Raman. In this section, we are going to discuss with solenoidal irrotational type of problem. Look at this problem. Find a constant A such that f vector equal to 3x minus 2y plus zi vector plus 4x plus ay minus zj vector plus x minus y plus 2z k vector is solenoidal. So the first question, the f vector is mentioned solenoidal. When it's solenoidal, to find the constant value. Then other problem, find ABC. So ABC constant, so that the vector f vector equal to x plus 2y plus az I vector plus bx minus 3y minus zj vector minus 4x plus 3y plus 2z k vector is a irrotational. So the problem is f vector irrotational, then find the value of the constant. Now first one is f vector is solenoidal, is given f vector is solenoidal. F vector is solenoidal is nothing but del dot f vector equal to 0. When the divergence 0, then it's a solenoidal. So del is nothing but I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. This is a value of del dot f vector 3x minus 2y plus z I vector plus 4x plus ay minus zj vector plus x minus y plus 2z k vector. So this is a f vector equal to 0. Now I dot I value 1, j dot j value 1, k dot k value 1, other value I dot j k, j dot I, j dot k, k dot I, k dot j values are 0. This is nothing but I dot I, j dot j, k dot k value 1, I dot j, j dot k, k dot I 0. Now when we multiply this, dou by dou x of 3x minus 2y plus z plus dou by dou y of 4x plus ay minus z plus dou by dou z of x minus y plus 2z equal to 0. When partial derivation with respect to x, the first term 3x, x only variable, other term constant. When dou by dou y, y is only variable, other term constant. Here z is a variable, other terms constant. When differentiate this 3, when I differentiate 3 into 1 minus 0 plus 0 plus here 4x differentiation constant 0 plus a y differentiation 1 minus 0 plus x differentiation 0, y differentiation 0 and 2 is a differentiation 1 equal to 0. For this term 3 plus a plus 2 equal to 0, a plus 5 equal to 0, then a value minus 5. So this is the first question. Answer: when f vector solenoidal, find the constant a. Then next, f vector irrotational. So irrotational is nothing but irrotational, given f vector is irrotational. F vector is irrotational given. Therefore del cross f vector equal to 0. Then the del cross f vector curl I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, and f vector x plus 2y, x plus 2y plus a z, x plus 2y plus a z, and then bx minus 3y, bx minus 3y minus z. This is the j coefficient. Then k coefficient minus 4x cy, minus 4x cy, and then plus 2z. 4x cy plus 2z. Now this is the determinant 0. This is a irrotational. Curl when 0, it's a irrotational. Now I vector leave this row and column. So generally what is the form? Minus, plus, plus, minus, plus, plus, minus, plus, minus, plus, minus, plus, minus, plus. This is a form. So first row only I am choosing here. Therefore the first row, first term plus. So I vector. Then for this term, when this cross, determine dou by dou y of cos, dou by dou y of cos, dou by dou y of minus 4x, just multiply minus sign inside this bracket, minus cy minus 2z, then minus, this is a z, dou by dou z. Now dou by dou z of bx minus 3y minus z. This is the I vector. Minus j vector, again leave this column and row. So dou by dou x of minus dou by dou z of this term. Dou by dou x of minus 4x minus cy minus 2z, then minus dou by j vector, minus dou by dou z, x plus 2y plus az, and then k vector plus k vector, when I am leaving column and row, dou by dou x of bx minus 3y minus z, then minus dou by dou y of x plus 2y plus az equal to 0. Now when I differentiate partially with respect to the first term y, this is the term y, z means this is the z, and x, this is x, z, then here x, here y. Therefore when I differentiate first term I vector, dou by dou y of minus c, other term 0, minus dou by dou z of minus 1, then minus j vector, this term minus 4, and then minus a, plus k vector b, then minus 2 equal to 0. Now this is a value, see, I vector 1 minus c, then plus j vector, when multiply minus inside the bracket, a plus 4, plus k vector b minus 2 equal to, the right hand side to consider the o is nothing but oi vector, oj vector, ok vector. Now comparing the coefficient of I vector, j vector, k vector. Therefore 1 minus c equal to 0, a plus 4 equal to 0, b minus 2 equal to 0. Comparison of I coefficient, then j coefficient, then k coefficient. Therefore this is a value c equal to 1, and a equal to minus 4, then b equal to 2. Therefore, A value -4, B value 2, C value 1 when F is irrotational. Thank you.